All right, now we're going to get into the heart of this unit. What is a mole? And Avogadro's number. You need to be familiar with both these vocabulary terms and their numbers. A mole is simply a counting number, just like we say a dozen when we mean 12. When we say a mole, we mean 6.02 times 10 to the 23 particles. And that definition helps us out with the next one. What is Avogadro's number? Well, it's 1 mole. It's how many particles are in 1 mole. So we're going to be using these as conversion factors a lot because they mean close to the same thing. They're definitely relatable. So let's do some work between molar mass and particles. So aluminum, the molar mass for aluminum, we take a look at the periodic table. I don't know what just happened here. Take a look at the periodic table. We see that aluminum has a molar mass of 26.98 grams per mole. Well, anytime we see particles, we need to use Avogadro's number and make sure you're using that E that we've talked about all year for the particles. Sodium chloride, that's NaCl. If we do the molar mass for that, we're going to get 58.44 grams per mole. Then how many particles in every mole? Well, that's Avogadro's number, 6.02 E23. Then dihydrogen monoxide. Remember, that's our fancy way of saying water. We do the molar mass for that. We get 18.02 grams per mole. And how many particles in every mole? That's Avogadro's number, 6.02 E23. So now we get to the actual definition of the relationship between these. What is the difference between a mole of elephants, a mole of feathers, and a mole of water? Well, if we take a look at these, particles always stays the same. The only thing that changes is going to be the mass. So if I have a mole of elephants, I've got 6.02 times 10 to the 23rd elements. If I have a mole of feathers, I have 6.02 times 10 to the 23rd feathers. But what changes is the mass. Or you can say molar mass, whichever one suits your fancy. Let's go on. Now we get to the math. When working with moles, molar mass can be used as a conversion factor. It's not going to be can be used. It should be will be used as a conversion factor. We're going to use this with your dreaded dimensional analysis. Don't freak out. These are very easy. Remember, all the way back to Unit 2. All you got to do is match up the units and put in the right conversion factors. So how many moles are in 28.7 grams of lithium nitrate? First thing you got to do, get the correct formula. Lithium is Li. I think you got a polyatomic coming up here. Nitrate is NO3 with a -1. That's LiNO3. Now you're going to draw your grid. We're going to start with 1 steps first, obviously. You put your given in the top left box, so 28.7 grams. If grams in the top left, grams are in the bottom right. Then our destination, moles, goes in the top right. We abbreviate moles by saying MOL. So how many grams in every mole? Get used to putting a 1 here, because you're going to do it a lot. Well, this is going to be the molar mass for lithium nitrate. I'm not going to go through every step. If you don't know how to do molar mass by this point, go back to the last video, look it up. But the molar mass for lithium nitrate is going to be 68.95. I don't know what just happened. 68.95 grams per mole. So that number goes here as a conversion factor, 68.95 grams in every 1 mole. That's how you read that. There's 68.95 grams in every 1 mole. That's what grams per mole means. So remember, you multiply the top, divide by the bottom. So you do 28.7 times 1. Make sure you use your parentheses. Divided by 68.95. Move that out of the way. That will give you 0.4616 moles of lithium nitrate. Get used to keeping track of what particle you're working with, because we're going to be switching particles very, very soon, the next day or two. Let's go on. We can't just stop one practice problem. Let's go on to the next one. How many grams are in Al2SO4? That's aluminum sulfate. They gave us the formula right off the bat. So we know we're going to have to go here. Put our given in the top left box. So 100 grams of Al2SO4 3. Grams in the top left, grams got to go in the bottom right. Al2SO4 3. We're finally going to end up and moles are up top. So we always have 1 mole. Now how many grams in every mole? Well, we got to go back and find the molar mass, which I abbreviate using mm. That molar mass ends up being 342.7 grams per mole. So that goes down here, 342.7 grams per mole. Don't need to have grams twice. So now you just do the math. 100 times 1 divided by 342. That will give you 0.29 moles of aluminum sulfate. There you go. That's your answer. We could have put 2 more zeros there to have significant figures. We factored in. So now, well, there's another polymer on too. So now we tell you to measure out 1.34 moles. These are going to be practice problems, so go ahead, pause these, and practice these on your own. All right, welcome back. This is how you should have solved it. The given, 1.34 moles, should have gone in the top left box. The destination this time was grams, so you make sure you didn't switch it on the right side of your train track. You should have gotten 24.15 grams. If we wanted to use sig figs, we would have gone with 24.2 grams of H2O with significant figures. Okay, the next one, I'm going to work this out, but you need to make sure you understand what you're doing. So pause it, see if you follow my work. Alright, so that's how you should have solved that problem. Remember, O2 is diatomic, which means there's 2 oxygens, not just 1. So if this number was 16, just make sure you know that diatomic means that it's going to be O2, not just O. Moving on. Once again, this one's a little bit more difficult. 256 grams of a pure monatomic element is known to be 2.26 moles. What element is it? This one requires a little bit of logic. If we remember, our molar mass is in grams per mole. We can write that differently by saying grams over mole. It means the exact same thing. So if we've got 256 grams and 8.26 moles, you do that math problem, and it gives you 30.99. Now that's actually your molar mass. So if you look on the periodic table and you look for 30.99, that's going to give you, don't know what happened again, 30.99 right there. That's going to be phosphorus, is that element. So take a little bit of logic and making sure you knew the units for molar mass, and that was all that one really was. All right, since we talked about Avogadro's number, now it's time to use that. So let's restate the meaning. Avogadro's number is 6.02 times 10 to the 23rd particles. Remember, it's the number of atoms in 1 mole of a substance. Also the number of molecules, number of formula units. You'll get used to it. So, our representative particles, if we have 1 mole of a monatomic element, we've got 6.02 times 10 to the 23rd particles, or atoms. If we've got 1 mole of a monatomic element, we have 6.02 times 10 23rd atoms of magnesium. We've got 1 mole of diatomic O2, or covalent compound O2. We've got 6.02 times 10 to the 23rd, and then diatomic covalent molecules, which we will now abbreviate as MLCl, of O2 or H2O. And any ionic bond would have 6.02 times 10 to the 23rd. Now for ionic compounds, this one's new, we're going to say formula units, which we abbreviate as FUs. Be careful with that. of whatever we're working with. So that's what the question's going to ask. It's really just basic vocabulary that you know molecules and covalent and ionic and formula units. So let's go more math. How many formula units are there in 7.55 moles of sodium? We're going to start off the same way. We have 7.55 moles, that's our given, so it goes right here. Okay, if we got mole on the top left, we got 1 mole on the bottom right. And up top, we're going to formula units, or the FUs. Now for we're going to particles, FU is a particle, we're going to use Avogadro's number, 6.02 E23. And you calculate it the exact same way. Just multiply those two together. You get 4.55 formula units of sodium sulfate, which would be Na2SO4. I don't know why I put the parentheses there. You definitely don't need them. So the next one, how many moles are there in that many particles? Just go in the opposite direction. But now this is our given. Start it off your box. 8.24. It's in the 23rd. Molecules, MLCl. So molecules there, we've got molecules down here. And anytime you see the MLCl, you know to put Avogadro's number in. We're going to find out how many moles we have. Moles is always 1 until next unit. Then it's 8.24 E23 times 1 divided by 6.02 E23. That will give you 1.37 moles of water. That's all it is. Alright, so these, number 3, number 4, I want you to go ahead and pause these, practice these, and see how you do. Okay, here's the work and your answer. If you don't know where you went wrong, go ahead and circle it, star it, and we'll try to fix that up in class. That's all we got for this video. Pause it if you need it.